Hey, everybody. Hello. Welcome back to the final event in the Flare Educate series. This is it, folks. After 4 weeks of diving into blockchain and EVMs and smart contracts in general, then in Flare itself, we have reached the final session, session number 8. Just as a reminder, all of the previous session recordings are available on our website and also the Discord channels. We've been regularly posting them, so if you want to catch up, I wholeheartedly recommend you to do so because they're terrific sessions. And today we're capping all of it with a session on creating custom FDC types, like I said. Our speaker, Anthony Madia from Flare, is once again with us today, and he'll be starting in a couple of seconds. And then when he finishes, I'll share more about what's coming up in collaboration between Flare and Encode Club. Specifically, there's a hackathon coming very, very soon, but more on that later. For now, Anthony, the floor is yours. Good luck.
Thank you, Neven. Are there any questions that anybody has so far on attestation types or FDC in general? Because I can address those and then tailor the presentation because it doesn't have to be as structured as the first few.
Yeah, that's a good point. If anybody has any questions, feel free to pop them in the chat, and Anthony will get them as soon as possible.
Yeah, and while that's happening, I'll touch a bit more on the attestation types because I think that the question that I received the most, and some of you have messaged me on Telegram, and I'll put my Telegram in the chat again, is how do I create my own attestation type? And that's what this presentation is going to focus on today, because if you look at the FDC attestation types, you see address validity, confirm block height exists, payment, reference payment, non-existence, EVM transaction, balance decreasing transaction, etc. And these are the attestation types that were initially created for something else in the Flare network called F-assets, okay, which we never described. But if you were going through the developer hub, you could see down here what F-assets is. And this isn't going to be a presentation on F-assets, but to give you a bit more context on FDC, FDC, again, to go back here, it's getting this, it's validating external data for Flare's EVM state. And for F-assets, we have these attestation types, which F-assets is, I'll just read it here. It's a trustless over-collateralized bridge connecting non-smart contract networks to Flare. And it enables the creation of wrapped tokens, which we call F-assets, for assets like BTC, Doge, and XRP, okay? And in order to create this bridging mechanism, we need to validate this external state using FDC. So that's why we have this address validity attestation type, for example, because with F-assets, you're actually creating the F-assets program is creating this address on that external blockchain like BTC or XRP or Doge. And guess what? We have to validate that actually happened. Okay, we want to make sure that a payment is made so we can mint and redeem on Flare's network and that BTC network. Okay, but how do you create your own? Okay, and that's what this presentation is going to focus on. Let's say you have a Web 2 API that you want to pull in data from and validate and use in your decentralized application. Okay, so how are you going to do that? I'm going to share with you something that is not listed as an attestation type on the developer hub. I'll pull that in, share that with you there. So this is the Flare specs repo. Okay, and I'll share this tab with you. This is what you should see, this repo, and we're going to go to the JSON API attestation type. So if you remember from the other ones, it's going to follow a similar flow. What's going to be different is the request body, because this has 3 fields, namely the URL, the post-processing, JQ, and all this is sort of like a filter when you call a Web2 API, you're getting this blob of JSON, and let's say you only want a specified field or fields within that JSON API. That's what the post-processing JQ is for, to define that, and the ABI signature or the struct for the encoding when you make a call to the smart contract, which we'll go over. Okay. So that's what you won't find in the attestation types. So let's go to the code here. I will share my entire screen. That seems to work better. And I will show you the code for using the JSON API attestation type. And before we do this, I'll touch a bit briefly on something that we did just to refresh everyone's memory on the flow of FDC. This is the address validity example that we showed you. Okay, the first thing that we did is we want to verify a certain address was created on another blockchain, and we chose the XRP address. This is the string for that XRP address. The first thing that we did was deploy this address validity checker. If we go to that smart contract, you'll see that this is one of the most important functions here, because this is what's going to verify the address validity. You'll have this on-chain verification, pulling in the contract registry, getting the FDC verification, and then calling this function verify address validity, and then passing in that proof. Okay, so we deploy that. This is it's deployed on Costin 2. And when you run this function yourself, if you're following along on your own machine, you can go to the Costin 2 block explorer and see that address. Then you prepare the request. Remember, you're getting the attestation type, which is the address validity hex encoded, and adding 0x to that. The source type, which is test XRP, which is hex encoded as well, and getting this appending the 0x to it. And then this is the request data, which is going to be passed into the fetch request. And all you need here is just one field. Remember the address string, which is this right here. You want to verify that this address was created on another chain. Then you get the response. These constants here are used to calculate the voting, the round ID, where the attestation request is going to be voted on by the data verifiers for FDC. Submits the request. This is the target round ID, which I hard coded because when that's created, you can always get that round ID and verify it. And you know what? Let's actually do that. Let's grab this target round ID that we looked at last time. Let's just put that in. This is the voting epoch where we have our attestation request voted on. And if you look sideways here, you'll see that it's a test XRP address validity attestation. Okay. Oh, yeah, I just realized I have to share that. Okay, let me do that real quick. Or maybe it did it for me. Okay. So this is what I was showing before. Maybe you saw it, maybe you didn't. This is the attestation request detail from the FDC to verify the XRP transaction. Then you're getting the proof. Remember, we have this proof flow, and then submitting that proof to the smart contract. So if we just run this example on the Costin 2 network, you'll see everything be generated. That's a voting round ID, prepared request, the data and proof that we want to see. We can see that it's valid. So that address was successfully created on the XRP blockchain proof and the transaction hash. And this is the result being true Boolean value for the XRP. So that was the flow there that we went over yesterday. But going back to today's focus on the JSON API, Web 2 flow here, it's going to follow a similar flow, just like the payment FDC attestation type that we went over on Monday, just like the one that I just showed you. It's going to follow a very similar flow. So what we want to do here is deploy the contract, and I already did that. I'll show you the Star Wars reader, and we're going to use this API here, which is a Star Wars API. And specifically, we're going to query and get the, this is the field that we're going to, the JSON that we're going to get when we call that API, the API up here. And it's going to give us all this information, but we don't want all that information. I'll show you how to define the post-processing JQ field to get the actual data that you want to bring onto the Flare EVM state. But this is what we're going to be using. This is the Web 2 API. So if we go back to the code here, after we deploy it to show you the smart contract, just like the other ones, we're getting this contract registry, and we're pulling in these, you're calling these functions the auxiliary, get iJSON API verification, and then calling the verify JSON API function. This is where you're passing in your proof. Okay, we're going back to the code here. After you deploy it, what are you going to do? You're going to prepare the request. Okay, so very similar to the other ones we went over, you have this hex encoded attestation type, you have the 0x, and the other source type is a Web 2. You add the 0x there, and then you create the request data field. Okay, and this is what it looks like. So the first field is a URL that you want to pull in that you want to make the API call to. This defines the fields that you want. So we want the name, the height, the mass, the number of films, and the unique ID coming from that specific request. So these are the fields. So if we just go very quickly back to that API, you're going to name, height, mass, the unique ID, and the number of films. Films is an array, so we are getting the length of that array to get the number of films. Okay, and then the API signature. So if we go back to the smart contract, how do we know what to define here? We look at the struct that we create. We're calling it the data transport object with the specific fields that we want: the name, the height, mass, number of movies, and the unique ID coming from the API. If you just look at how we're using that in the smart contract, you'll see that it's used to decode the API, or not the API, the ABI coming from the smart contract here. This is how we add characters to this smart contract. This is how we're adding data. This is how we're getting data from a Web 2 API. Okay. And then very similarly, like the other ones, we call it response using the JQ verifier URL, which I can share with people who message me on Telegram, and then following the same flow. Okay. So we deploy the contract, we prepare the request. Now we submit the request. And I won't touch much on this because it's really the same flow as the others. We have a target round ID. I already did this myself to ensure that it works. This is a round ID that we're going to have our JSON FDC attestation request voted on to ensure integrity of the data, and then getting this proof. Very similar to the other ones here. So nothing crazy. And then we submit that proof. We're grabbing the contract here. We're adding, and then we're calling this add character function. If we go back to where I showed you the data transport object, it's being used in this add character function defined on the the smart contract. Now there is this field here that's requiring the character's application ID to be 0, which means that we haven't called it before. Considering that I have used this before, we're going to see this message character already exists. So we'll see it revert, but that's fine. Okay, we're just talking through how this all works. And then you'll see this code here, which actually adds the character, grabs the name, the number of movies, the API unique ID, and the mass of the character. You'll grab that character, then push that ID into this DTO that we have here. So after submitting the proof, then we can call that. So let's actually run this, and then we'll look at the smart contract on the Costin2 network to grab the characters and really see how it works. So preparing the request. Okay. This is the response that we get. ABI encoded data. And then we get this, like I mentioned, reverts because I already added this. Okay. So if we want to actually see how this smart contract works, we can just grab the contract that I deployed earlier and go to the Costin2 block explorer, paste in that address. This is the contract that we deployed. Okay. You see that it was created. You can go to the contract here, same contract that I showed you. Read and write. So let's see if we can get the characters here. Yep. So this is the data that we brought on chain. This is the character that we added. It was R2D2, the number of movies, and 6 movies, the API UID, and the mass. And if we go back to the API that we called, it's getting the same information. Using FDC, using the JSON API, number of movies here, 1, 2, 3, 4, 5, 6. And using FDC, the new JSON API. Okay, that wasn't so bad. This is the flow of how it all works. And let's call the character IDs. Well, let's see. Okay, let's forget that. So that's how it's working. It works on Costin2 and it works on the Costin network. Very similar to each flow, but maybe you'll have to spend a bit more time understanding this. This is a bit unique because it's grabbing the ABI signature, which may take some time if you're not familiar with that. But this defines the fields that you want. And just focus on the name, height, the mass, number of films, and your UID, which matches the post-processing JQ here. Okay. And once you know the format or the type of that state that you're bringing in, then you just define that as a string, a uint 256, and matching the smart contract that you write. Okay, and that's really about it for the creating your own attestation type. So I'll give a high-level overview here. We wanted to we wanted to make a call to the Star Wars API. We called it here, and the data that you get is the R2D2, Star Wars character, etc. We deploy the contract. We made a call, which we would make a call to verify, have this on-chain verification, prepare the request. Just like the others, we get the response. We submit that request using this function. We can check in on the voting. And let's actually do that because we did it for the other ones. So if we go here, let me just paste the round ID in. We can see how the voting happened. And you'll see, just like we saw with address validity, if you turn your head to the right, you can see the JSON API and the Web2 type there. Okay. Very similar. If I go back to the address validity voting round, voting epoch, you can see that they voted on the verifiers voted on that here. Then you get the proof, and then you submit the proof by calling that smart contract. I'll give you that list of characters that I showed you directly on the Gaussian block explorer. So does that make sense to everybody? Now's a good time to go over some questions that I can directly answer.
Yeah, looks like we have a couple of questions which you piled up while you were presenting. While we go through them, everybody else, in the meantime, you can maybe come up with some other questions. But for now, let's scroll back up. There was a question at the beginning from Jake saying, do you perhaps plan on introducing any other stock types aside from these 6?
Yeah, so I mean, if you want to bring in, if you're talking about stocks and you want to bring in price feeds, FTSO would be the use case for that. But if you want to bring in like a certain API call related to stocks, then you can use the JSON API that I shared with you. You can just use that type.
Cool. Next up, there is a question from Kenny. Kenny said, could you share the Flare Hardhead link once more, please?
Sure. Let me just go to. I'm assuming you're talking about the flared hardhead starter.
Yeah, exactly. And after that, there's a question from Aman saying, is the Oracle truly trustless, meaning no dependent on single failure or point of failure? If need to be built for independent off-chain data?
Yeah, so we have this the voting round. If I just go back to the voting round and I'll share this tab, this is how we get this integrity of data on the Flare network, because we have multiple people, multiple nodes voting on the veracity of this Web 2 data that we're bringing onto the blockchain. Okay, and there's financial incentives involved. We rely on this economic theory on the Flare network. So that's how we get this trustless. We don't have a single point of failure for this off-chain data.
Yep, makes perfect sense. All right. Now there's a question from Muhammad. How much gas can I expect to pay on Flare?
Well, that depends on how much you use Flare. It's a standard. I mean, it is an EVM chain, so it's a similar to how much you would pay for a transaction on um, different chains, or how congested the chain is at a certain time period. But it depends on how much you're using the blockchain.
Yep, makes sense. There was also a question from Kenny earlier, which is not directly related to what we're doing here, but maybe we can bring it up. Kenny said, I'm working on creating a crypto wallet just for fun. Are there any repositories on GitHub that can help me with this? Like, do you have anything to recommend?
There's I'm not sure if MetaMask is open sourced, but there's definitely a lot of I would just look for. I'd probably ask Grok on Twitter that question. If you find any repos related to building my own crypto wallet, and you should find some open sourced, well supported projects for a crypto wallet. And you'll be surprised. It's not as hard as you would think to create your own crypto wallet, especially when you're using someone else's project to start with.
Yeah, absolutely. New question from Aman. Okay, the transactions can be highly time sensitive. How can you minimize the latency in transmitting off-chain data to the on-chain FDC?
Yeah, we I believe there's 1.8 seconds for the FTSO price feeds, and FDC is dependent on the APIs that you're using. So it's you can't guarantee a specific latency dependent on that. but it does. We have a set structure for FTSO that is different for the FDC. So it's hard to answer that question specifically, but how it minimizes latency in transmitting off-chain data. Yeah, it's really dependent on those APIs that you're using.
All right. Any other questions? Yep, Ivan is typing something. Let's give it a minute.
Sure.
In the Cool, got it. Okay. In the meanwhile, Anthony, since this is the final session, do you have anything more that you? Okay, just a question from mine. Let's go back to that. FDC type safeguard against potential collusion between off-chain data providers aiming to mislead your system.
Well, that's where the economic theory comes in. So they would be slashed and lose whatever they staked to be a verifier. So that's how we mitigate against that.
Cool. All right. Yeah, like I was saying, this is the final session. So anything else that you want to share, Anthony, with the people who are attending now that this is the final session? Anything which might have been missed over the last couple of weeks? Anything that you want to address, or have we covered it more or less?
Yeah, we more or less covered the basics of Flare, how it works, FDC. I mean, it is an EVM based blockchain, so there's plenty of support for building on EVM chains. But stay close to the Flare hardhat starter, because we're going to be making updates to that if there's any other changes to be made. And I'll share my screen again. You can just look through the commits as well to see what's happening. So like, I mean, if you're having some problems related to versions, most likely it's a periphery package that was bumped. So I'd pull the latest there. You can see we just changed it to 0.1.2, and then it's to 1. That was changed. If you look at any others, if you look at the access to the periphery packages, that changed as well. So just make sure if you have any problems when you're running the Flare hardhat starter on your own machine, just ensure that you're getting the latest version, and that should probably fix problems that you might be having. And if you do have any other problems, I've listed my Telegram a few times. Just message me. I'll be happy to get on a call with you to go over any problems.
Perfect. All right. Now that's pretty much it. Let me share my screen a little bit, and I want to show you something. So, like I said, the Flare Educate series is only the beginning of the collaboration between Anchor Club and the Flare Network. We are continuing with the Flare Hackathon starting on the 1st of April. We've already announced a couple of different bounties for the Flare Hackathon. One is called the most innovative use of Flare protocols for the new wave of blockchain applications, which basically asks you to use pretty much any of the protocols or oracles that we covered over the last couple of weeks, the FDSO, the FDC, or even Flare's random number generator. And yeah, let me paste the link in the chat to access the site. You can register right now. So yeah, there's also an additional bonus track bounty for best external data source connected to Flare. So yeah, basically we've covered a bunch of Flare related things. As things got as things progressed, we got more. We dived deeper and deeper into Flare. We got more technical, and we'll also be hosting a couple of workshops for the hackathon itself, specifically designed to bring you up to speed about these bounties and give you some ideas on what to build. So yeah, feel free to join us on the 1st of April for the launch event for the Flare Hackathon. And good luck building. Until then, see ya around. I hope you apply all of this knowledge gathered over the last couple of weeks to good cause. And yeah, thank you very much to Anthony, who covered most of these sessions, and thank you very much to Philip as well, who isn't here, who covered one of the sessions too. We are looking forward to seeing you again in a couple of months at the Flare Hackathon. Until then, stay cool and see you around, everybody. Bye-bye.